the previous video, we have considered the energy levels of an electron in a hydrogen atom and discussed Pauli's exclusion principle if a system contains more than one electron. That is the case if we consider all other elements in the periodic table. Let's consider the next element after hydrogen in the periodic system, the helium atom. In its nucleus, it has 2 protons and 2 neutrons. Since neutrons do not have a charge, the charge of the nucleus is determined by the 2 positively charged protons. Around the helium nucleus, 2 electrons are in orbit. This system has similar electronic states in the first, second and third shell as the hydrogen atom. One of the electrons has a spin up, as indicated with the red arrow up. One electron has a spin down, indicated with the red arrow down. Following the Pauli's exclusion principle, both electrons can be in the ground state. This means that the helium atom in its ground state has its 1s level fully filled. If we now move to the next element in the periodic system, the lithium atom, the nucleus has besides 3 neutrons, 3 protons and 3 electrons in orbit around its nucleus. Following the Pauli exclusion principle, the third electron cannot join the 2 other electrons in the 1s ground state, because whether it has a spin up or down, it will always be identical to one of the other electrons in the ground state. As a result, the third electron will fill the next lowest state, which is the 2s state. The next element in the periodic system is beryllium, which has 4 electrons in orbit around the nucleus. These 4 electrons fully fill up the 1s and the 2s electronic states. The next element is boron. It has 5 electrons in orbit and can fill up 1 electron in the 2p states and has a total of 3 electrons in the second shell. The next element is carbon. It has 6 electrons in orbit and can fill up 2 electrons in the 2p state and has in total 4 electrons in the second shell. So basically, carbon has its second shell not fully filled. As we discuss in the next block, the electrons in the not fully filled outer shell are responsible for making the bond with other atoms in molecules or solids. As carbon has 4 electrons available in the not fully filled shell, carbon can make 4 covalent bonds like in methane gas or in diamond. The next element is nitrogen. It has 7 electrons in orbit around the nucleus and can fill up to 3 electrons in the 2p state. The next element is oxygen. It has 8 electrons in orbit around the nucleus and can fill up to 4 electrons in the 2p state. It starts to get boring, isn't it? Fluor has 9 electrons in orbit around its nucleus and can fill up to 5 electrons in the 2p states. Neon has 10 electrons in orbit around its nucleus and fills up 2p fully with 6 electrons. Neon fills up fully the first and second shell. We also know that neon has a very low chemical reactivity, similar like helium, which fully fills up the first shell. Both elements belongs to the noble gases. This indicates that atoms with only fully filled shells cannot easily make bonds to other atoms to make molecules or even solids, while atoms with not fully filled outer shells are able to make bonds. The next element, sodium, fills the 3s state with 1 electron. The magnesium fully fills up the 3s state with 2 electrons. Aluminium fills up the 3p state with 1 electron. And finally, we arrive at the most important element for photovoltaics application, silicon. Because note that 95% of the commercial available solar panels is based on silicon. Silicon has 14 electrons in orbit around the nucleus and fills up 4 electrons in the 3s and 3p states. These 4 outer atoms are the weakest bounded to the nucleus. Similar like in the case of carbon, the 4 outer electrons of the silicon atom will play an important role in making bonds with other atoms in a molecule or in a solid. How do these molecular bonds determine the band gap of silicon? I will give the answer to that question in the next video.